Hello, I thought that I would pop on and make a really quick video about one of the problems that shows up in the homework for chapter 3. It is a little bit of an extension from the stuff that we talked about in class, so I thought I would go ahead and make a little video about one of the problems. It's number 14, and it involves the composition of functions. Remember that the problems may change a little bit from person to person, or if you try a new problem, the number might be a little different, but try to follow along with the idea. That's what's important. So this particular problem says, use the graph to answer the following question, or problem, sorry. G of f of -7, or another way to say it is G after f of -7. So if we look at the graph, we have two functions. The red one is f of x, and the blue one is g of x, and we need both of those. First, I'm going to go ahead and rewrite our problem. I'm going to write it g of f of -7. So really, I need to find f of -7 first, and once I know that value, it will get plugged into the function g as our input. So right now, we know that we want to find f of -7. That means the input is -7. We want to know what that output is. So the x is -7. We want to know the y. So if we look where x is equal to -7, that is right here, and it hits that red graph. Let me kind of zoom in a little bit. X being -7 is right here, and we're looking for where it hits that function f. We want to know the y value when x is -7. So the y value right here is 0. It actually has a height of 0. So f of -7 equals 0. We can rewrite our original problem. It was g of f of -7, and we just found that f of -7 is 0. So that means this is the same as g of 0. So we're doing something very similar. We know that x is 0, our input is 0, and we want to know the output if we're talking about the function g, which is the blue function. So we're looking now for where x is 0, that is right here, and we want to know where that hits the g function. That's going to be right there. That's where this whole line, this whole fabulous dotted line I'm making, this is all the area or all of the times where x is equal to 0. For example, this isn't needed for this problem, but just to play around with it a little bit, f of 0 is where this dotted line I've made at x equals 0, where that hits the f function, the red function, which is g. Not needed for this problem, but good to practice. So we want to know where the g function sits when x is equal to 0, and I'll go ahead and change color once more. That's right there, right? The height or y value is 2. G of 0 is equal to 2. That means that the point 0, 2 is on g. Meaning if x is your input, 2 is your output. But just go back to right here, g of f of -7. First, apply f on x is -7. That output was 0, right? Let's translate that into a point. If f of -7 equals 0, the point -7, 0 is on the function f. When x is -7, y is 0 when we're talking about the function f. So our output for f of -7 was 0. So we applied g on that value. G of 0 was 2. So that is our final answer. Hey, I'll even put that in there. Although I can't submit it, this is just a screenshot. But hopefully this helped with this problem. If you want me to try working out another one that's very similar to this, I can try refreshing it and getting different numbers. Let me know or shoot me an email. Otherwise, I hope this helped with this problem a little bit, and I hope you have a good weekend. Bye.